So in this video we'll solve problem 3 here. The last two videos, problem 1, problem 2 we were solved here. Now this is the third problem related to the thin cylinders. Okay. I'll read first. We'll read the problem and we'll check what are the data he's given. Then we'll note down and then we'll try to solve the unknown values here. Okay. So if you go to the problem here, a cylindrical pressure vessel of 1 meter in a diameter. Okay. So data first we will write here. The inside diameter of the thin cylinder is given. What is the given data here? 1 meter in a diameter, that is d equal to 1 meter. Convert the meter into millimeter because normal all the conversions, the units are in mm only. This will be equal to 1000 mm. So in a diameter is 1000 mm is there and 1.5 meter long. Its length is 1.5 meter. Therefore L equal to 1.5 meter. It is the 1500 mm. 1500 mm long is subjected to an internal pressure P. Okay. P, it is subjected to an internal pressure P. We don't know the value, he is not given. What is the fluid pressure here? Okay. Next, thickness of the cylinder wall is 15 millimeter. Wall thickness is 15 millimeter. That is T equal to 15 millimeter. Okay. And taking allowable stress for the cylindrical material. Whatever the cylindrical material, its allowable stress is 90 MPa. So allowable stress means maximum stress allowed from the cylinder. That is allowable stress. That just I write here. So cylinder, it can allow maximum stress is, allowable stress is 90 MPa. 90 megapascal. MPa means Newton per mm square only. So no need to convert here. It is Newton per mm square, megapascal. So it's the allowable stress is 90 MPa maximum. You have to determine, the first one is the magnitude. The first one is what he is asking, magnitude of maximum internal pressure that can be withstand. How much pressure P that can withstand in the cylinder. Okay, the fluid pressure maximum, how much it can withstand. That is P equal to how much that it can withstand. So second one is the change in dimensions. What are the change in dimensions? In the last problem we solved here, the change in diameter, change in length, and overall total change in volume. Right? Three data we have to find out here. So second one, we have to find out change in diameter equal to how much, right? Change in length equal to how much, and change in volume. Total volume change is how much. This is the second bit. Take Young's modulus E equal to 200 GPa. He is given E equal to 200 GPa. Convert this into MPa. Megapascal is nothing but Newton per mm square. It means 10 raised to 3, right? 10 raised to 3, 200 into 10 raised to 3 MPa. So that will be nothing but 2 into 10 raised to 5. That is 3 and this is 2. 5 MPa. That is 2, directly I'll write here 2 into 10 raised to 5. Or you can write 200 into 10 raised to 3. Both are same. This is MPa, Newton per mm square. And one more data is given, Poisson's ratio, nu. That is nu equal to 0.3. So this is the data he is given here. Okay. So diameter is given, length is given. You have to find out the allowable stress. Allowable stress is given. The maximum allowable stress is given. It is the 90 MPa is given. Okay. And your thickness of the wall thickness is given 15 millimeter. And you have to find out the maximum the pressure of the fluid that can withstand. First bit. And second one, all the changes of the cylinder. Diametrical change, length change, and the volume change. These four data you have to find out here. Okay. So now we will solve. Data are here. We'll try to solve the problem here. Okay. We have two types of the stresses developed in the cylinder, right? Already we discussed and we solved the problem also. One is circumferential stress, one is longitudinal stress. two types of the stresses developed. Circumferential stress is PD by 2T and longitudinal stress is PD by 4T. Okay. So out of these two, if you see the equation here, which stress is more in the cylinder here? Here divided by 2 is there, here divided by 4 is there. So obviously this circumferential stress is more in the cylinder compared to longitudinal stress. Okay. So longitudinal stress is half of the, can I say longitudinal stress is half of the circumferential stress? Because here 4 is there, here 2 is there. Okay. First one is the circumferential stress is maximum compared to longitudinal stress. And second point is the longitudinal stress is half of the circumferential stress. I'll derive here, I'll check here. Okay. See, so for this one, just check it. PD equal to how much? 2T into sigma C, right? From this one, PD equal to how much? 4T into sigma L, right? So both equate. Now 2T into sigma C, because both left side are same, 2T into sigma C equal to 4T into sigma L, right? Therefore, the longitudinal stress sigma L equal to 2T into sigma C divided by 4T, right? Divided by 4T. So here sigma C by 2. Can I write sigma L? So sigma longitudinal stress is half of the circumferential stress. So circumferential stress is double. It is more. Now in the problem he is given the maximum allowable stress. Maximum allowable stress is out of these two. Which one is maximum here? We have to start design with respect to which one? Which is the maximum? This is the maximum here. This is double. So can I write the sigma allowable, whatever he is given, equal to sigma C? It is the maximum allowable stress, circumferential stress, equal to 90 MPa, right? 90 MPa. So this is the data he is given here. The circumferential stress is maximum. Now first try to find out the P here. The first bit is circumferential stress. Apply the circumferential stress equal to PD by 2T, right? PD by 2T. Now maximum allowable stress is circumferential stress, that is 90 MPa. 90 equal to P is, you have to find out maximum pressure, how much inside the fluid, into diameter is how much? Diameter of the 1000 millimeter, that is 1000 millimeter divided by 2 times thickness is 15 millimeter, wall thickness is 15 millimeter. Okay, so from this one the maximum pressure of the cylinder we can calculate here, right? Therefore the P equal to, from this one, P equal to, you will get the 2.7 Newton per mm square or MPa, both are same, Newton per mm square. This is the first bit. Maximum pressure, or you can write, okay, P max or maximum pressure, it can, because we are allowed, we have taken the maximum allowable stress with the consideration here. So that's why the generated pressure also maximum. Now we know sigma C. How we will calculate the longitudinal stress here, because further calculation we required. Okay, this is the first bit finished. Now longitudinal stress equal to half of the circumferential stress, as I derived here, half of the circumferential, sigma C divided by 2. You remember this equation also. Okay, so how much is there? This is 90 divided by 2. This is equal to 45 MPa. 45 MPa, that is longitudinal stress. Okay, I'll write here this is nothing but sigma C and sigma L. How much I calculated here? 45. Just for further calculation, 45 MPa. Now we will go for the second bit. What he's asking, change in diameter and change in length. Okay. Okay, how we'll start the change in dimensions? Start with the change in diameter first. If I need the change in diameter, it is related to circumference, right? So we have to apply the circumferential strain. Okay, as two problems we solved, we applied so many times the formula here. So first I will go with the circumferential strain, right? Circumferential strain equal to, what is that? change in diameter, how much change in diameter with respect to original diameter, right? That is change in diameter divided by original diameter. So we need change in diameter. How much change in diameter he is asking here. I know the original diameter here, right? Original diameter is 1000 millimeter of the cylinder. Then I need for the different substitution for this because I don't know, he is not given direct, right? So we know the circumferential stress and circumferential strain already just now we are calculated here, sigma L and sigma C, right? Apply the Hooke's law, same. Apply the Hooke's law, how will convert here? Strain equal to stress by E, sigma C by E minus nu into Poisson's ratio into sigma L divided by E, right? This even previous video also we substituted like this, equal to change in diameter divided by original diameter. Now substitute. The sigma C is how much? The 90 MPa divided by Young's modulus already is given, the 2 into 10 raised to 5. 2 into 10 raised to 5 MPa minus Poisson's ratio is 0.3 is given into longitudinal stress we are calculated just now. It is half, 45, right? 45 divided by 2 into 10 raised to 5 Newton per mm square equal to change in diameter we have to calculate divided by original diameter is 1000 mm. 1000 mm. Okay. So now from this only one is unknown data, right? Only one is unknown data. Calculate the change in diameter. From that, therefore, change in diameter, simplify and calculate. Change in diameter is equal to 0.383. 0.383 millimeter. See here, for this allowable 90 MPa allowable stress, okay, the diametrical change, the increase in diameter is 0.3 millimeter, almost 0.4. 384 means almost 0.4 millimeter it is increasing. Okay. Now we'll go for the change in length. How much change in length? Again increase in the length here. How we'll go? For related to this longitudinal strain, right? Now apply the longitudinal strain formula. Longitudinal strain formula equal to change in length divided by original length, right? How much it will be change in length? That is change in length divided by original length. Same here, this is the length here. Now we need the change in length. We know the original length of the cylinder. Original length is 1500 mm, right? So now again apply Hooke's law. How will apply? Strain is stress by E, sigma L by E minus nu into sigma C by E, right? Equal to change in length divided by original length. Now substitute the values. The longitudinal strain is how much? Longitudinal stress is 45. 45 half of the circumferential stress divided by 2 into 10 raised to 5 is Young's modulus minus Poisson's ratio is 0.3 into circumferential stress is allowable stress. It is 90 divided by 2 into 10 raised to 5 equal to change in length is we need calculate, and the length of the cylinder is 1500 mm. So one is unknown data. So from this simplify and calculate how much length change of the cylinder. Okay. So from this after calculation you will get the change in length is 0.135 mm. See here, diameter is 0.4 almost 0.38. Diameter is more and length is less. Okay, so 0.135. Now change in diameter finish, change in length finish, and pressure is 2.7. Already we are calculated, right? That is 2.7. This is already we are calculated 2.7 MPa maximum pressure. This is also finished. Now find out the volume change. Okay, volume change. How will start the volume change here? How will start the volume change? Again apply the volumetric strain. Same like this. So volumetric strain equal to change in volume divided by original volume, right? How much volume change with respect to original volume? We know the change in volume, right? So it means original volume. Original volume is area into length. Area is pi d square by 4 into length. D also we know, L also we know. We can calculate this one. We want the change in volume here. Then come to this one here. We have one relation. Volumetric strain in terms of volumetric circumferential strain and the longitudinal strain, right? Already we applied so many times. Volumetric strain equal to 2 times circumferential strain plus 1 time longitudinal strain. This formula you have to remember, and we are applied also in the previous videos while solving the problem. Apply the same here, okay? Apply this one, that is 2 times circumferential strain plus longitudinal strain equal to change in volume divided by pi d square by 4 into L okay. Now substitute. So this is 2 into again apply the same Hooke's law, sigma c by E minus nu into sigma L by E. Sigma L by E, this is the 2 into strain, the circumferential strain, plus sigma L by E minus nu into sigma c by E, right? This is one term equal to dV, change in volume divided by pi d square by 4, that we will apply later, that is pi d square by 4 into L. Now substitute the values. 2 into circumferential stress is the 90, right? 90 divided by 2 into 10 raised to 5 MPa minus Poisson's ratio is 0.5 into 45 divided by 2 into 10 raised to 5 plus sigma L is how much? The 45 divided by 2 into 10 raised to 5 minus nu is 0.3 into 90 circumferential stress divided by 2 into 10 raised to 5. This is 1 equal to right side now. Change in volume divided by pi by 4. D is how much? Diameter. Diameter already 1000 is given, right? 1000 square into length 1500. So this one is left side equal to right side. So left side everything values are there, and right side only all the values are there except the change in volume. Now simplify and calculate the change in volume here, okay? So change in volume we will get the directly after simplify and calculation. So change in volume is 100.73 into 10 raised to 4 mm cube. This is the volume change here, okay? This is how we have to calculate. The only remember, if maximum allowable stress he is given in the problem is, that is nothing but the circumferential stress. There only maximum stress is acting, because two types of the stress we know that, the not longitudinal. Longitudinal is half of the circumferential stress. That also we are applied here in this equation. In the problem, if he is given the maximum allowable stress, just take that one as circumferential stress, sigma c, and proceed as usual, okay?